Alright, so now I want to focus on non-uniform motion. What happens when acceleration is not 0? So up here I'll put acceleration is not equal to 0 meters per second squared. Okay, so you're changing your velocity. I can determine the goal for today. I can determine the instantaneous rate of change of an object, and that's going to be the challenge of the day. Okay, this right here. From a displacement time graph and create the resulting velocity and acceleration time graphs. So for this, you're going to need a ruler, very important. And what we're going to do, we know that in order to go from a displacement time, and if you'll notice below, I've got the VT and AT. So with mine, I'm going to have to draw it like this. If we want to go this way, I got to find slope. Now, hopefully, most of you realize from math that when you have a curve, there's no slope. Okay, it's a whole bunch of different slopes. The slope is changing at each segment along this graph. All right, so how do we determine the velocity? Well, what we do is, what the method I prefer, is we select 3 regions. We select starting region, we select some mid region, and then we select some end region. So we're going to end up getting 3 velocity points here. All right. The reason I like taking the first point at 0, 0 is that I ask people, what is the velocity at stage 1 here? So what is the slope? Well, it starts off, if I grab my ruler here, right at 0, 0, it starts off as a horizontal line. Okay, so at that point in time, right at 0, 0, it's a horizontal line. It's a horizontal line, the velocity is 0 meters per second. So that's an easy point to get. The next one, the next 2 points are a little bit more challenging. So when I look at this, I see it goes up to 8 seconds. I don't want to pick 4 and 8 because 8 doesn't really show up. So I'm going to go with 3 and 6 as my other 2 points. So here is the process and a challenge for you with the ruler. We use the ruler's notches. So the notches represent the, say, the measurement 5. The task is, and clear rulers work the best, is that what you're trying to do is that I want that point, the red dot that I have there, I want the curve, and I'll just emphasize, the curve leading up to it. Let's say it stopped curving. It actually shot off straight. I want the notch on my ruler to represent that straight shot of motion. So I adjust it so that if the graph ended there and it started going straight off, my notch would represent that projection or that direction. Once I have that lined up perfectly, take my ruler, take a pencil, and I draw the longest line possible on the provided grid. All right, so I will draw it that long. So I cover the entire grid. Next, I'm going to move the ruler to the next red point and repeat. So again, I want it to match up with that line. So tip it a little bit more maybe. There we go. It looks like it takes off from there. And I repeat. Again, I draw the largest possible line possible. And now I'm done with my ruler. Okay, oops. So what I'll do is, I'm going to get rid of my ruler. Get it out of my way. Gone. These 2 lines represent perpendicular lines to the tangent. We are looking for tangent. All right, the slope of the tangent. So put that off to the side. So instantaneous rate, instantaneous rate of change is the slope of the tangent line. Now, it's virtually impossible to draw a really nice tangent line using a ruler off a curve because you never know when it's perfectly tangent. By using the little notches, we guarantee that the line that we drew is perpendicular to the tangent at that point. So the other thing I wanted to remind you of, if I have a slope, which is delta y over delta x, and I want to find a perpendicular slope from grade 9, it is the negative reciprocal of your original slope. Okay? So what we're going to find the slope of these two lines that we drew, and then find the negative reciprocal. That will give us the slope of our tangent line. So for slope 1, which is actually velocity 1, so I'm not going to use that. I'll use v1 is equal to, actually, you know what? I know why I use m. I'm going to find the slope of line 1. So delta y over delta x, that's equal to. Now the trick here is to find points. The reason I have you draw it so big is so you can find points that are easy to create a triangle. So right there, for example, is a nice point. And after that, we're going to have to pick one based on the grid I've created. This looks like approximately halfway through a time interval. So I'm going to use this triangle here. Creates my right angle. So here's my delta y. And that's equal to, going up by 1s, 5. My delta x here is going to be a half. So that means I will have 5 divided by 0.5, and it's a negative slope. So that means my answer here would be negative 10. All right. Now we want the velocity. The velocity at this stage is the negative reciprocal of my slope. So we need to flip it and change the sign. So it becomes positive 1/10 of a meter per second. Okay, and that's the answer we're looking for. So we construct these perpendicular lines to our tangents using the ruler, and then we can calculate the slope. So this is definitely the more challenging of the processes here. So step 2, I'm going to find the slope of line 2, which is delta y over delta x. Again, the reason I have you expand it out is so that you can find some points to find that slope. And it's the same thing where I'm going to have to pick one, and that, eyeing it up, looks like halfway there. Dropping my line down, across. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like I have 8 there, and that's 1.5 there. So my slope of line 2 is 8, it's negative again, over 1.5. Doing the math, comes out to be approximately negative 5.33. So that means that my V2 is equal to negative 1 over that reciprocal. It's going to become a positive, and when you do 1 divided by the 5.33, we get about let's call it 0.19. So it's going to be about 0.2 because I want to graph so accurately. So I'll convert the 1/10 then. We know that's the positive 0.1. Okay? So there we have it. We have 3 points, and they're at those given times. So you can move downward. I'm going to move to the next slide here. Here's my velocity. I'm going to have to change my scale, and this happens often in this particular section. I'm going to go up by 0.1s. So that's actually going to be 0.5. That's going to be 1.0. That's going to be negative 0.5 and negative 1.0. All right. So I know at 0 seconds, the velocity was 0. All right, so flipping back, and you're just looking upward. At 3 seconds, and that's where I took the next point, my next red dot was at 3 seconds, I know my velocity is positive 0.1. So 3 seconds, positive 0.1. I know at 6 seconds, it's positive 0.2. With the grade 11 course, the velocity time graph will always be a linear relationship. Okay? I'm not going to have it, and you'll find out in the calculus and vectors course and the 4U physics, and we can talk about it in class if you want, why it's always a line and why we don't get into the curves. Okay, so your velocity time graph for this type of this section will always look like that. It's always going to be a line. All right. Now we can determine acceleration because we know if we want to go from a VT to an AT graph, we're finding slope again. All right. So we find the slope of that line. Keeping it simple, I'm going to use that triangle right there. So 0.1 and 3. So my slope here, which will be my acceleration, so I'm going to go acceleration equals delta y over delta x. Now we didn't have to do this yesterday or last lesson because we were looking at a horizontal velocity time graph, so acceleration was always 0. So we get 0.1 divided by 3. So we get 0.03 now, repeated. And that's meters per second squared. So now you're going to change that scale again. And I'm going to go up by 0.01s, which means this is 0.05, and this is 0.1, negative 0.05, negative 0.01, oh, 0.1. Okay, and my line will be a horizontal line here. It's going to be at 0.03 roughly, a little bit above. That's as close as I can get. Maybe slide it down just a little bit. So there we go. And there's our acceleration. And that is the process of the steps for you to get from point A to point B here. All right. For the next one, I have one going downward. So I'm going to start this one and I'll finish the examples in the next video once I get to the quitting point here. So once again, I pull out my trusty ruler and 3 regions again. Again, always start over here. All right, and this one goes to 10 seconds. So again, you can pick the ones you want. I'll go 4 and 8. All right, doesn't really matter. It'll give you close to the same answer every time. Again, if the graph starts out looking like this, looking horizontal, we know that V1 is going to be equal to 0, so we don't need to do any calculations. The other 2 points, though, this is where you need to manipulate your ruler. And again, remember what I said. You're basically wanting the curve to end and head off straight. So you can see here, oops, come on, it's not too bad. Okay, you can see where this curve looks to now just go straight off following my ruler. All right, and I think I need to tip it just a hair more. Something like that. Once you have the ruler where you're happy, this is where you draw in your lines as big as you can. And again, you might not get the same numbers as mine. I am using fairly clunky ruler to work with here. It's always a little bit easier using real rulers. So if you're off or you're finding that your numbers aren't the same as mine, then that's not a big deal. Okay, so there we go. I've got my 2 lines that are perpendicular to the tangent. Okay, so again, remember they're perpendicular to that tangent that we are looking at. So perpendicular, or close to perpendicular. So for this one, I'm going to go line 1 and 2 again, do my calculations. So, oops. So line 1 here. Actually, I guess I should number them 2 and 3, just because I've already gone with a V1 over there. So M2 is delta y over delta x. So now we're looking for points that we can use to create a triangle. I think I found some. Not too bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like I got about 13 over a time frame of 1 second. So that means that the answer there is 13. So my velocity again is negative 1 over that value. So it'll be negative 1/13. And we're going to convert this to a decimal anyway, so it doesn't really matter when you do that. So that's going to look like, say, 0.08, and it'll be a negative meters per second. All right, so I'll pick up the next video at this point, and we'll finish off the last couple of examples.